Howdy folks, and welcome back to Advent of Code 2024. It turns out that each one of these days has two parts to it, and in the previous videos I did not realize that, which I feel like I should have realized because you're supposed to get 50 stars, and there's only 25 days, and obviously 25 days you get 1 star. You know what? I wasn't paying that much attention. Pay attention to your requirements. So this is day 1, part 2. Two lists of location IDs are indeed very difficult. Yeah, because we basically got like 1.6 million as our total distance. So yeah, very different. Or are they? Ooh. Historians can't agree on which group made the mistake or how to read the handwriting, but in the commission you notice a lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time you need to figure out exactly that. I mean, that actually happens more often than you'd think. And we actually have specific AIs that are designed, or machine learning algorithms that are designed to figure out various handwriting. You need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Here are the same example lists again. Okay, so this list and this list. The first number on the left list is 3. It appears in the right list 3 times. The similarity score is 9. Second number is 4. It appears there. Third number is 2. Does not appear in the right, so the similarity score is not increase. So basically, we're trying to calculate. You can see I screwed that up. We're trying to calculate the similarity score. How many times each of these numbers appears in the other list? Okay, so let me actually open. Let's see. Okay. Puzzle input has not changed. Okay, so that's good. So what I actually want to do, you see I've renamed these this code from the last time. Let me actually go ahead. I'm going to grab these that put them into lists because I want to keep that. That code is still good. Okay, so let's do this on the sample. So what we want to do, we've got list 1 and we've got list 2, and we need to find out how many times each of these appears in this list. Now, what that means is for this list, we actually want to calculate how many times each of those numbers appears. Like that would be the easiest way. We could do this in an O of n squared way, where we could actually take for each number in list 1, we'd loop over all the numbers in list 2, and if they are equal, increment a counter. That would actually work, but what I'm going to do instead is I'm going to turn list 2 into a map. That way we can actually do this as an O of n solution because we're just looping over list 1 and list 2, but not nested. So, list 2, let's call it frequency map. And we're going to loop over const item of list 2. Actually, that looks exactly what I want. So that is, thank you, AI. So that'll basically say, okay, we start off, if we have the item in our list already, we increment it. If not, we set it equal to 1. This is not exactly how I would have done this. I would have done a slight tweak, but the algorithm's the same. So now frequency map will be a list. It'll be a key where the key is the number and the value is how many times that number appears, which means if we go here, frequency, that's not a thing at all. So it's going to be frequency map or 0. So basically, if it doesn't appear in the frequency map at all, we'll just use 0. And we'll just sum those up. And then we'll log. Wow, that is a hard word to spell. Okay, let's try this. Node 2. Okay, assignment to constant variable, right, because total frequency should be a let. Okay, so we got 10. Oh, that doesn't seem actually quite right. That's not what it is. It's multiplied. They're multiplied together. So it actually, so the frequency map of the item, number of times, so total frequency is actually going to be, no, that's actually correct. That should be fine because it's plus equal to the frequency. Okay, just make sure I'm using the right sample list. Yeah, looks right. Okay, well, let's log this then. Console log item frequency. Okay, so we get 3. That's 3. Okay, so in this one, it is 9 plus 4 plus 0 is 9, 9, and they got. Oh, right. Okay, it multiplies it every time. All right, so that actually does need to be item times frequency right there. So it's not just adding it. It's not adding the 3 every time. It's adding, like it's multiplying it. And now we get 31. Okay, and then let's run this over our input 1. Okay, we get. So, see, the thing is, I don't think this is a useful number for anything. Cool. Okay, so now we have two of them. I don't think that's a useful number. Like I don't agree with that method of finding frequency or anything, but you know. Okay. Now let's also take a look at part 2 because, there's a second star to be earned here. What is this? Why is there a star here? What does that mean? This is slowly spelling out something, I guess. That's kind of cool. I like the way of this site. It's pretty nice. Okay. So, cool. The engineers spread to a low number of self-reports. There was problem dampener. Tolerate a single bad level in what would otherwise be a safe report. It's like that bad level know what happened. Okay, so this is a little bit more complicated because now we actually have to know how many bad levels we found. So if you remember with part 2, if a level would make it non-descending, okay, which would be in this case where ascending, descending, that's bad. Or if a level would jump too far, like for example, we've got this one 2 to 7, or in this case we've got 4 and 4, right? So they're saying if there's just one mistake in there, then we're fine, basically. So here, like, okay, if we remove any level, tolerate a single bad level, this is safe, this is safe. This one, if we remove that 3, it would be safe because now it's just going up, right? Technically, you could also remove the 2 as well. Safe for removing the 3rd level, 4, all right, that should be fine. These ones, it doesn't matter because let's say I remove that 2, right? There's still the gap there. 7, that gap is too big. Same with here. And that, excuse me. And I imagine if you had something that was ascending by 2 and then descending by 2, it also wouldn't work. Okay, so let's actually then open that up. Right, okay, that's fine. And let's copy just, you know what, actually, part 2 is going to look very similar to part 1, I think. So I'm just going to copy the whole thing because, yeah. Okay. Okay. So now in this case, we're checking the report, is safe, is safe. So there's a couple ways we could do this. We could actually go through the report and delete certain items. That's kind of the lazy way to go about it. So let's pull in sample. The lazy way to go about it would actually just be to look through this entire report, loop over it again, and remove that particular level and see if it passes. And if any of those reports pass, then we're fine. So let's actually just write that right now. So this would actually be the same report.length I plus plus, and then I'm going to copy it actually. Report copy equals report, and then I'm going to delete that specific element at I, and I actually want to start with I is 0. Because I want to go over the whole thing. So report copy, there we go, splice, and it removes that I. Now, we're going to take that whole loop in there and indent it correctly. And we're going to use report copy instead of report. Okay, and this is going to be here as well. Okay, and so what we're going to do now, this is safe. I'm actually going to leave that in here. So you might remember the first time I talked about this, I talked about how we're assuming this is safe until proven otherwise. We're actually going to do the inverse for this whole length of reports. So is any safe equals false. And then down here, we're going to say if is safe, is any safe equals true. And then just like before, we break, because if we found any of these that are safe, we don't need to continue on. You might say, oh, why don't we check the entire report as well? We could, but it doesn't actually matter, because technically any report that is in its entirety working, so like this report, for instance, should be fine if I remove the first or last element. It should still be totally fine. Like a subset of a report that is good should also be good. So I don't need to check the entire report at all here. Okay, now outside of, let's see, there's that loop. This needs to go inside the inner loop. And then I actually want is any safe. Then we're actually going to increment that. Okay, so what have we done? This remains unchanged. And that's kind of the easiest to handle it. Like this code is exactly the same. And this is actually how we handle algorithms like this. We just add more stuff to it. You know, the original algorithm is working, and it still is working as it is, so we just add some more stuff. Now what we're doing is we're basically just going around and adding loops or making it more complicated. We're just removing every single item and trying the report without that level. We'll see how it goes. Part 2. Okay, so now we have 4 safe reports. Let's see if they got that. Okay, yeah, 4 reports. Okay. So let's try that with our data. Oops, not that. Okay, so now we have 612. So before we had 572. Now we have 612, which actually isn't that much more, especially out of 1,000. So I'm a little suspicious of that, but let's just see. 612. There we go. All right, so that is the second parts of Challenge 1 and Challenge 2 for Advent of Code 2024. Thanks for watching. I'll see you all next time.